Hello friends. So in this video I am going to talk about the next generation core, that is the architecture for the 5G technology. As we have discussed the all 4G technologies, 1G, 2G, 3G and 4G in the previous lecture, and today we are moving into the 5th generation, that is 5G technology. So here the next generation core is the core architecture for the 5G technology, which is equivalent of the evolved packet core in a 4G network. 5G NG core architecture supports virtualization and allows the user plane functions to be deployed separately from the control plane functions. So it supports both the international mobile subscriber identity, that is IMSI, which is based on, and non-IMSI based identities for authentication of services. So this NG core is having the following detailed system architecture. So that is, the first one is authentication server function AUSF. So in the middle we have AUSF, AMF and SMF. So the first among them is AUSF, that is authentication server function. It performs the UE authentication, that is user equipment authentication, using extensible authentication protocol. The next one is the AMF, that is the access and mobility management function. It is responsible for connection management, registration management and mobility management. Then the third one is the SMF, that is uh, session management function. So before going to that, we'll have the DN, that is data network, which offers the operator services, internet access and third party services. Network exposure function NEF, the proxy or API aggregation point for the core network. It provides the security when services or external application function access the 5G core nodes. NRF, that is network respiratory function. It supports service discovery and maintains provides profiles of network function instances. NSSF. The NSSF is the first block which is in the diagram. That is, NSSF is the network slice selection function. It supports the selection of the network slice instance to serve the user equipment. Because today we are having more number of networks. In India we are having around 3 to 4 networks that are sponsored by the foreign, and the Indian networks are Airtel network, Jio network, all those things are there, and Vodafone Idea, that is VI, all those things are there. So these networks are being selected by the this network slice selection function. And policy control function, it provides a unified policy framework and shares the rules to the control plane. There are certain rules which are given in the network topology that has to be followed when we are designing the mobile phones and when we are using the 5th generation architecture. Then the session management function, UE IP address and allocation and management. The session management, as the name implies, that it segregates the address, which means that the user equipment IP address are being allocated and managed by this block. Then UDM, that is Unified Data Management. It provides authentication and key agreement credentials. User plane function UPF, the last row, the last before component, that is UPF, user plane function. It provides a packet routing and forwarding functions. In addition, it also handles QoS services, that's quality of services. AF, that is application function. The application function interacts with the 5G core to provide services such as application influence on traffic routing, accessing network exposure function. The next topic is a virtualized evolved packet core. So functionally similar to the physical EPC, however the way in which the EPC is deployed and managed is different from physical EPC. So there are two types of modeling, that is EPC setup has been given, that is two methods in which virtualized evolved packet core can be deployed are an all-in-one virtual EPC, all-in-one virtual EPC. Then the second one is the standalone instances of MME, BGW, PCRF, or even as GWHSS. So it is easy to manage the EPC instances on the entity. However, it lacks mechanisms to individually scale one or more services. Architecturally, the EPC, virtual EPC, will be different from that of the physical EPC, following that some of them the key architectural differences between physical and virtual EPC are: a virtual EPC may have one or more VM for each of components. For example, PCRF services may have multiple microservices. Each of the microservices may run on separate VM or a container on the Techno cloud. The subscriber session state information in a physical EPC may be stored in RAM of or transient memory in the hardware. A physical EPC achieves high availability and reliability by deploying multiple physical instructions of the EPC hardware. So these are the two things were given. Then a subscriber state information in a physical EPC must be stored in a RAM or transient memory in the hardware. It achieves high availability and reliability by developing multiple physical instances of circuit. So hope you have understood the 5G network architecture and the virtualized evolved packet core. Thank you.